what has to happen here? So you only have logarithms on the left-hand side of the equation. So the first step is to combine them down to just one logarithm. So when you do that, here you would use the product rule. And you really end up multiplying the y minus 1 times the y. And if you want to go ahead and do that, you end up with y squared minus y. Next, since you only have a logarithm on the left-hand side, the next step is to convert it to an exponential equation. So when we convert it, what would that look like? Good, so 2 to the first equals y squared minus y. Now 2 to the first is the same thing as just 2. Now we're trying to get everything to the same side since we have a variable squared. So we get y squared minus y minus 2 equals 0. And then now we just try to factor that quadratic on the right there. So negative 2 up top, negative 1 down below. So those factors would be negative 2 and positive 1. So we get y minus 2, y plus 1. And then you're solving each of those by setting them equal to 0. So here you end up with two solutions, positive 2 and a negative 1. So just remember, you always want to go back and check these solutions in the original logarithm. So if we plug these back in, which of those solutions would not be good? The negative 1, right? Because it would cause this value here to be negative as well as that value there to be negative. So you cannot take logarithms of negative numbers. Any questions over that first one? So let's look at this next one. Is an exponential equation. You have exponents on both sides. So the first thing to do is just to combine it down. Where you just have one on each side. So here, there's already just one on the left-hand side. How would you combine both of these terms into just one? So what are you doing with these exponents? Adding them, right? So here, if we added them, you'd be 3 to the negative 5th. So x plus negative x cancels each other out. 2 plus negative 7 is negative 5. Now that you have the common base on both sides, so we have the base of 3 on both sides, so now we can just drop off the base and set these exponents equal to each other. So now we're just setting 2x minus 5 equal to negative 5, and then solving that equation for x. So we get 2x equals 0, divided by 2, we get x equals 0. So it is possible to have negative exponents. And it's not possible to have negative values after the logarithm. So here, 0 would end up being a good solution. Any questions over that exponential equation? So this last one, once again, you just have one exponent on the left here. So the whole goal is to start by getting this e to the power of 3x by itself. So we're going to start by subtracting 9 from both sides. So we get e to the power of 3x is equal to 18. Now that we've isolated that exponential term on the left-hand side, e to the power of 3x, now we can convert this into a logarithm. So what would this look like as we converted it? We have log, what's the base in this case? E. What would the next value be? 18 equals the exponent 3x. So log base e is the same thing as a natural log. So really in your calculator here, you're just going to plug in the natural log of 18, figure out what that number is, and then divide by 3. So what do you get when you plug that into your calculator? Just the natural log of 18. 2.89. And that you're still going to take and divide by 3 in order to solve for x. 0.96. You can round those just to 2 decimal places. Any questions over any of those? So if you have only one side that has exponents or only one side of the equation that has logarithms, once you isolate it, you're going to try to convert it to the opposite form. If there's logarithms on both sides or exponents on both sides, you get the common base or the common logarithm, and then drop it and set those exponents equal to each other, or it comes after log. So we'll get to the quiz now. I'll let you guys work through that.